you see over here is John Louis Calment celebrating her 122nd and unfortunately the last year on Earth. According to Guinness World Record revised in 2020, she is the oldest of all times. Living that long or maybe more may sound insane. But what if I say in near future it would be nothing but usual? Good evening, it's Tulbar from Biology Department, and in this presentation I will talking about two therapeutic approaches that slow down the rate of aging, thus have potential to extend our lifespan. These are senescent cell therapy and NAD++, as you can see in the outline. So let's move on to the first therapy, senescent cell therapy. Senescent cell can be seen as zombies inside of us. I call them zombies as they don't die when their expiry date comes like all other normal cells do. Instead, they start harming the other healthy cells around and eventually causes diseases like diabetes or kidney failure. Most of you can associate these diseases with old age people. In fact, it is the case, as senescent or so-called zombie cells build up in body more and more as time passes. So scientists have tried to find the ways to remove those zombies selectively without damaging the healthy ones. As I mentioned earlier, those cells are immortal as they don't receive signals to die. So in research conducted by John Hushang in the Department of Pharmacological Sciences in Arkansas University and his colleagues, the mice were injected with substances that drive senescent cells to commit suicide. This 2015 study, published in Nature Medicine, clearly illustrates that 80% of senescent cell has been disappeared after the injection. In order to see the effect of this treatment, I would like to show you the picture of these two mice before and after the treatment. As you can clearly see, the mouse on the left before the treatment looks way more older and sicker with his wrinkled ears and eyes. So having covered the first therapeutic approach, I would like to draw your attention to the second one, NAD+ pills. NAD+ is a helper molecule that enables cells to maintain their integrity, identity, and therefore functioning. In contrast to senescent cells, those NAD+ molecules decline with time as we become older. This drop creates terrible mess inside of the cell and may bring several other diseases with itself, including the heart-related ones, Alzheimer's, and cancer. To emphasize how critical role NAD+ plays in body, co-director of Paul F. Glenn Center for Biology of Aging at Harvard Medical School, David Sinclair says, "It is one of the most important molecules for life to exist, and without it, you are dead in 30 seconds," in his interview on February 15, 2018, to Time newspaper. So scientists, including the Sinclair himself, has started to find the ways to boost NAD+ molecule inside of the body. But there was a problem to be overcome. The molecule NAD+ cannot enter directly into the cell from the outside. Instead, a solution, a precursor, or in other words, molecules that are able to enter into the cells and then convert it into NAD+, has been discovered. In order to test the efficiency of this conversation, again, Sinclair put drops of NMN, which is one of the precursors that I have just mentioned, into the water for a group of mice and observed the differences in a period of time in his study published in journal Science in 2017. As you can see, the two mice treated on his lap walking on the moving walkway are at the same age. One of them is treated or has given with the water that includes the NAD plus boosting precursor, while the one on the right has given plain water as a control group. When you compare those two mice, you can easily detect the one on the left, the treated one, runs way faster than the other as a sign of health. As a conclusion of this experiment, an AD plus boosting precursor in a form of dietary supplement has been produced for the sake of healthier and younger life. This brings me to the end of my presentation. Today I've tried to explain the two ways of rewinding clock for all of us. But don't forget, science needs repeatable and good data. So even though the human trial for these approaches has been started, it would take some time to make them accessible to all. Thank you for your kind attention. If you have any questions or comments, I would gladly accept them. And for those of you who are interested in, here is my reference list.